Hello students, today we shall discuss about the thermic process in metallurgy. Thermic process is one of the processes of the metal extraction. Okay, then we will start. The electrochemical series or the series of metals according to activeness. The electrochemical series we shall know first the electrochemical series, that is the series of metals according to their activeness. The series is given below. We will write the series. The series of metal according to activeness. Or we can say this series, the electrochemical series. The series is given below. Lithium, potassium, barium, calcium, sodium, magnesium, aluminium, manganese, zinc, chromium, iron, cobalt, nickel, tin, lead, hydrogen, copper, silver, mercury, platinum, and gold. Lithium, potassium, barium, calcium, sodium, magnesium, aluminium, manganese, zinc, chromium, iron, cobalt, tin, lead, hydrogen, copper, silver, mercury, platinum, and gold. In this series, if we follow the series from the upper portion to lower portion of the series, the activeness of metals will be decreased gradually. So, according to activity, we can write Li greater than potassium, greater than barium, greater than calcium, greater than sodium, than magnesium, greater than aluminium, greater than. This is the syringe. Now we will discuss about metal extraction processes. There are a few metal extraction processes according to activeness of the metals in electrochemical series. So we will write the processes by numbering 1, 2, 3, etc. First of all, the process is electrolysis. It is electrolysis process for lithium, potassium, barium, calcium, sodium, aluminium. The metal extraction process is used. Number 2, the process is carbon reduction process. carbon reduction process. What is the process? Okay, carbon reduction process is also called smelting. Carbon reduction process is used for metals less reactive than carbon, such as iron. In that case, the process is used to extract the metal. Number 3, reduction with more reactive metal. Reduction with more reactive metal. This process is called displacement. For metals that are more reactive than carbon but can be displaced by other metals like sodium, potassium, iron, etc. This process is used to extract the metal. For example, when iron is added to copper sulfate solution, copper is displaced by iron. The reaction is given below. Here, Fe is more reactive than Cu. So, Cu is displaced by Fe, but Cu is more reactive, Cu is more active than carbon. So, Cu cannot be displaced by carbon reduction process. With more reactive metal is applicable, and that more reactive metal is Fe. Fe displaces Cu from CuSO4 and Cu is extracted. Number 4, the thermic process. Thermic process involves a metal oxide and a more reactive metal. The reaction between metal oxide and more reactive metal produces high temperature because the reaction is exothermic reaction. Example, 1 ore of iron is iron oxide, Fe2O3. It is mixed with more reactive metal aluminium, Al. Actually, aluminium powder is taken here. The mixture is called the thermite mixture. The, the mixture is called the thermite mixture. Thermite mixture is mixture of Fe2O3 plus aluminium powder. How the process is started? Now let us see. To start the reaction in the thermite mixture requires a high temperature, which can be achieved by igniting the mixture. Sometimes, in that case, we use a magnesium ribbon. Thermite mixture. What is thermite mixture? Thermite mixture. Fe2O3 plus in the form of powder. The reaction can be written in this way. The reaction between Fe2O3 and aluminum powder. This reaction will start if the mixture is igniting. High temperature. In this reaction, the products will be Al2O3, Al2O3 plus Al2O3 plus Fe. If we want to make balance, then this will be 2Al plus heat. Heat will be produced because this is an exothermic reaction. In this reaction, Fe is extracted from its pore Fe2O3. This is the thermite reaction. The application of thermite reaction. We shall see how this thermite reaction is applied in practical purposes. As the thermite reaction is exothermic, the high heat is produced. As a result, as products, molten iron and Al2O3 are produced. This molten iron can be used to weld broken iron parts such as rail line. In the figure, right side of this page has been shown how the broken rail line is welded. Okay, this is for all for today, and the next day we will discuss another topics.